The AP Calculus Exam 2023 Free Response Question Number 1. Getting gassed up for integration. A customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, where f of t is modeled in gallons per second and t is measured in seconds, since pumping began. Selected values of f of t are given in the table above. What we'll do first is we'll model the situation by plotting a graph. Plotting the points from the table and connecting it with a smooth curve gives us an idea about what the graph is, f of t in gallons per second. Part A. Using correct units, interpret the meaning of the integral from 60 to 135 of f of t dt in the context of the problem. Then use a right-Riemann sum with the three subintervals shown here to approximate the value of this integral. Calculating this integral would help us find how many gallons would have been entered into the tank over the course of the time between 60 and 135 seconds. Alright, so now we're going to calculate the Riemann sum using these three subintervals to approximate the area under the curve, which is the integral, from 60 to 135. Breaking it up into the subintervals, the Riemann sums are going to be using rectangle areas to sum up the area under the curve, to estimate the area under the curve. And this will represent again the total amount of gasoline pumped into the tank from 60 to 135 seconds. Doing this Riemann sum, we take the height at the right side of the interval, multiplied by the width of that interval, and here we get 8 1/4 gallons. So over the course of this time span, we should expect to accumulate 8 1/4 gallons. So that's the answer to part A. Now, part B. For part B, must there exist a value c on the interval from 60 to 120 such that the derivative is equal to 0 at that point? The mean value theorem suggests that there is. The slope of our secant line is equal to 0, and so also by the intermediate value theorem, the existence of such a value must be concluded, and this is all based on the fact that since f of t is differentiable, it is also continuous. Some integration. Part C, the rate of flow of gasoline in gallons per second can also be modeled by g of t, given here, on the interval from 0 to 150. Using this model, find the average rate of flow of gasoline. By definition, the average rate or average value is 1 over the length of this interval multiplied by the integral of that function over the interval, and our calculator gets us 0.95996692, etc. Now, if we want to do this integral directly, let's let I be this integral, and I'll pull out any constants that I need to here. So I'll pull that constant of 500 out. Next, we'll make a substitution to make that integrand a little bit easier to deal with. Choosing z equal to t over 120 will do the trick of simplifying the integral to this new integral with new limits of integration. But we'll have to do another u substitution here, or u equal to z squared will do the trick here, and now we get an integral that's just a cosine integral, with new limits of integration and a new constant in front. And evaluating this, the integral gives us the exact value of 12 over 125 multiplied by the sine of 25 over 16. And that is the exact value of the approximation we got earlier from our calculator. The average value. Last part. So now, in our gas station problem, Part D says, using the model G defined in Part C, find the value of G prime at 140 seconds and interpret the meaning of the answer in the context of this problem. So here's our function for G of T, the rate of flow of gasoline, and here's the derivative, which we find using the chain rule and as well as the product rule. And substituting in the value of T equals 140, we can evaluate this expression. And we get this value. And because of it being negative, it's telling us that the flow is decreasing at 140 seconds. It is decelerating in a sense. Gallons per second squared could be thought of as gallons per second per second. Well, that's it. Problem number 1 of the free response questions 2023 AP Calculus. I hope you enjoyed this video. Please hit that like, subscribe, and notification bell for more videos, and stay tuned for the next one. Thanks for watching.